So today what we're going to do is we're going to solve by elimination. Now, when we're solving by elimination, what we're talking about is taking two linear systems and identifying the like terms and making sure that they are aligned, right? Now, if the like terms are the same, then there's nothing left to do other than to subtract or add. So we choose those variables and then we eliminate them. Now, if there's a problem where we have our variables the same, but the coefficients in front of those two numbers are different, then we need to multiply one or both of those two equations by a factor. And that's why I kind of say, well, what is the LCM? And what we're going to do is we're going to either add or subtract the two types of equations. And then what we do is we back substitute our first solution back into one of our other equations and then calculate our checks. Now, let's begin our first problem. We're going to solve by elimination. So now we have this new equation, x plus y is equal to 8, and x minus y is equal to 4. Both equations have an x term, so in this case, both of them have the same coefficient. So what we're going to do is we're going to subtract them, okay? And that's it, really. Okay, and so when we subtract both equations, we're going to get, well, x minus x is going to be 0, and then what we're left with on the other equation is going to be 2y. Now, that operator that I put there just tells me whether you're going to be subtracting or not. So in this case, we're going to get 2y is equal to 4 because we have the following. Y minus negative y equals 2y. Now, I know that when I subtract x minus x, I get 0. That's why I don't even bother writing it in that second line. And then we end up with y is equal to 4 over 2. And we end up with y is equal to 2 as our final answer. Now that we've got y is equal to 2, we have to back substitute. So we're going to go and take y equals 2, and we're going to substitute it back into the first equation. And you know, when you do these problems, I expect you to actually say what you're doing. Now notice how I've got my description, my flow of information moving down the page constantly. Just identify what you're doing in each section of the page, and we just substitute. So we get x plus 2 equals 8, and our final answer is x is equal to 8 minus 2, which means x is equal to 6. And now what I want you to do is practice your check from last time. Pause the video and see if you can do it. Then press play to see if your solutions are correct. Okay, good luck. And now we'll move on to question number 2. Now what you're going to notice is that you have two equations with 2x at the front of them. So in this case, when we have the same coefficients on our x's, we're just going to subtract. Negative 4 minus y gives us negative 5y, which is equal to, well, 14 minus 4 is just going to be 10, I believe. And then, once we've got that, we have to isolate for y. So we're just going to say negative 5y is equal to 10, and I know some of you do this form for division. That's perfectly okay. I'm just showing you. And we end up with y is equal to negative 2. Now that I've got y is equal to -2, we need to back substitute into one of those equations. I chose to use the second equation instead of the first equation. It's all up to you. Okay? But make sure you write out the actual equation on the set. Now we end up with 2x plus bracket -2 minus 4. And you'll notice how I'm always making sure that I put my substitution in brackets. And we end up with this final set. Now, once I've got my 2 points, what I need you to do is I need you to go back and I need you to make sure that you check this. So there's our answer for our first check, and there's our answer for our second. Pause the video and copy this down. The last thing you should add is your final solution statement. And we're going to say, therefore, let's scratch this out. Therefore, the solution is and then we'll just put 3 and -2. So now let's move on to our next problem for the day. Example 3. Example 3 says to solve by elimination these two equations here. X minus 4y equals 2 and 3x minus 7y equals 7. So because I want to take a look at the x terms and I want to cancel them, you'll notice there is no 3 pattern here. So in order, what we're going to do is we're going to make sure that the first equation has a 3. And remember how we always wrote our transitional line, R implies. In this case, we're going to multiply the first equation by 3 in order to ensure that the coefficient on x is 3 for our first equation. And we get the following. 3x minus 12y equals 6, and the bottom does not change. And now that we have our new system, what we're going to do is we're going to subtract these two. 3x minus 3x is 0. But -12 minus -7 gives us -5y for our y's. And here is what we would do as an aside. And 6 minus 1 gives us 5. Going through the motions, we end up with y is equal to -1. And I apologize, I just noticed this extra bit of work here at the bottom of the screen. Don't want it. Just getting rid of it now. Now let's continue on with the rest of this problem. Now what we're going to do is we're going to go and back substitute. We're going to back substitute our work into this equation here. So we know that y is equal to -1, and we're going to back substitute and get our final answer. You'll notice how important it is to label what we're doing, and make sure that you actually state the equation you're subbing into. Now, here's what we get for our substitution. You'll notice that I've left a space in the second line. What I'm doing is I'm considering what the multiplication of 7 times -1 gives us. That's -7. I'm going to leave that in a bracket here. And now we go about simplifying. So we have x is -2 as our final solution, and then state your final statement. The solution is the point -2, -1. Now let's move on to our final problem of the day. So this problem here, we're looking at the x's and we look at the y's. You'll notice that the x's and the y's, well, yeah, they don't match. The coefficients don't match. So what we're going to do is we're going to use the concept of the LCM. And what I would tell you to do is use the LCM on either the x's or the y's. I would suggest you do the x's. In this case, we get an LCM of 15. So now we're going to transform each of these equations. For the top equation, we're going to multiply the equation by 3 in order to get them to match, and we're going to end up with this. 15x minus 9y equals negative 15. Now, let's do the same for the bottom. This time we're going to multiply by 5, and we get the following. And now, let us subtract. So now when we subtract, we get the following. 1y is equal to positive 5. So y is equal to 5 in this case. I'll put in blue the reasoning to the right and to the left of our equations. And there's your justification for our coefficient of 1, and there's our justification for our constant of 5. Now let's back substitute y is equal to 5 into the second equation in our system. As usual, first state what you're going to do. And now back substituting will give us the following result for the first two lines. So you'll notice that I have 3x minus 2 times bracket 5 equals negative 4. And you'll notice this blue line that I'm putting underneath the 2 and the bracketed 5. So imagine that you're just focusing on that. Calculate your work and put your result into this bracketed result. Then go and simplify after that in order to get the appropriate answer. So I now have 3x minus 10 is equal to negative 4. And then move the negative 10 to the other side. And we end up with 6 on this side, 3x. Go through our calculations, we end up with x is equal to 2 as our final solution. So now state your final statement and we're done. And we state the solution is xy equals 2, 5. Have a good day. Get the rest of the work done.